A formal variable description is called a data type. A variable or constant that is defined concretely by data type is called a data object. The figure shows how data types can be used.
ABAP standard data types predefined by SAP or implemented types are divided into two groups.
The implemented ABAP standard data types that already contain a type-specific, fixed-length specification are considered a complete data type.
The standard types that do not contain a fixed length are considered an incomplete data type. When they are used to define data objects, you need to specify the length of the variable. Using standard data types, you can declare local data types in the program that can be more complete or complex than the underlying standard data types. Local data types only exist in the program in question and hence can only be used there. The declaration is made using the types statement. A data type defined in the ABAP dictionary is called global, as it can be used throughout the entire SAP system concerned. You will only learn how to describe the data elements and use them as field types. Categories of data types: standard, local, global. These types will be used to define variables or data objects. Data objects are always defined with a data keyword. You can use an ABAP standard type, a local type, or a global type to define a data object. You can refer to a presently defined data object when defining additional variables, such as like addition. You can use the value addition to pre-assign the value of an elementary data object. If the length specification is missing from a variable definition, a default length for the incomplete standard data type is used. For example, length 1 for types C, N, and X, and length 8 for type P. If the data type is missing, as well, the standard type C is used. For example, the data GV_myVar statement having no type and length specification defines a type C variable with length 1. For more details, refer to the keyword documentation for the types or data statement. Fixed data objects have a fixed value that is defined when the source text is written and cannot be changed at runtime. Literals and constants belong to the fixed data objects. You can use literals to specify fixed values in your programs. There are numeric literals, which are specified without inverted commas, and text literals, which are specified with inverted commas. In figure text symbols, you find an example for a text literal at the third line of the right statement. You define constants using the constants statement. The constants type is defined similarly to the definition of elementary data objects. The value addition is mandatory for constants. This is how you define the value of constants. A very important principle in ABAP development is multilingual capability. This means that the logon language of the current user is taken into account when texts are displayed on the user interface. The use of text literals in this context is critical because the literal exists in only one version in the source code and is language independent. Only create language-dependent texts as text literals for testing purposes. For productive programs that are executable with various logon languages, the ABAP programming language provides the text symbols. Each text symbol is used in the particular program to which it belongs. These symbols are stored outside the source code in their own repository object, the text pool for the program. Text symbols can be translated into various languages, and each of them is stored with a language indicator in the text pool, as shown in the figure. If the program accesses a text symbol when it is executed, The system takes account of the logon language of the user and supplies the text in this language. A text symbol is identified by means of a 3-character alphanumeric ID -XXX. To use a text symbol in your program, you need to address it as text-XXX, where XXX stands for the 3-character text symbol ID. To make specifying a text symbol more intuitive, you can also use the following syntax instead of text-XXX or ... in inverted commas, XXX in brackets. Here, ... in inverted commas should be the text of the text symbol in the original language of the program. Options for defining text symbols for your program. In the ABAP editor, choose Go to, Text Elements, Text Symbols. Address the text symbol in your source code using the syntax text-XXX or ... in inverted commas, XXX in brackets, and double-click its ID for forward navigation. To translate the text symbols of your program, choose Go to, Translation from the menu in the ABAP editor.
Local data types can only be used in their defined programs. Global data types, in contrast, can be used throughout the entire system. Global data types have the following advantages. Global data types can be used throughout the system, which increases the system's consistency. The fact that they can be reused reduces the amount of maintenance effort required. Global data types can have a where-used list generated in the ABAP dictionary. The where-used list includes repository objects that use the data type in question. Global data types can contain semantic information that corresponds to the business descriptions of the objects to be defined in addition to technical information. They can then also be used for designing screen displays, for example, the shop description on the left of the input field. Local data types should only be used in the program where they are defined, and only if the semantic information does not matter for the definition of the corresponding data objects.
When you start a program, the program context is loaded into a memory area of the application server, and memory is made available for the data objects defined in the program. Every elementary data object is pre-assigned the type-specific initial value, except if a different value was set using the value addition. The clear statement resets the contents of a data object to the type-related initial value. For detailed information about the initial values for a particular type, refer to the keyword documentation for the clear statement.
In the case of functions, the opening parenthesis is part of the function name. The rest must be separated by at least one space. Standard algebraic rules apply to the processing sequence. Expressions in the parenthesis come first, followed by functions, powers, multiplication and division, and addition and subtraction. For more information about the available operations and functions, refer to the keyword documentation for the compute statement.
In ABAP, depending on certain conditions, you can execute various sequences of statements in the following ways. In the if construct, you can define any logical expressions as check conditions. If the condition is met, the system executes the relevant statement block. Otherwise, the condition specified in the next else-if branch, where several branches are possible, is checked. If none of the specified conditions are fulfilled, the else branch executes, provided it exists. The else-if and else branches are optional. For more information about formulating a logical expression, refer to the keyword documentation on the if statement. In the case construct, you can clearly distinguish cases. the content of the field specified in the case part is checked against the data objects listed in the when branch to see whether they match. If the field contents match, the respective statement block is processed. If no comparison is successful, the system executes the other branch if it is available. Except for the first when branch, all further branches are optional. In both scenarios, the condition or match check happens sequentially from the top down. As soon as the statement block of a branch executes, the system immediately jumps to end if or end case. The figure shows several simple examples such as negation and all links with parentheses and negation before logical conditions of using the if statement. You can formulate negations by placing the not operator before the logical expression. When negating the is initial query, you can use the special is not initial query. You can nest the if and case structures in any way, but make sure that the logic of every structure is correct here. Every structure must be closed. For example,
there are 4 loop constructs in ABAP. The system field will make sense only if queried within a loop. In nested loops, SY index always contains the loop pass number of the loop in which it is located. In the do and while loops, the SY index system field contains the number of the current loop pass. Hence, you should only query this system field within a loop. Loop constructs. Unconditional and index-controlled loops. The statement block between do and end do executes continuously until the loop is left using termination statements, such as exit. Specify the maximum number of loop passes, otherwise you may get an endless loop. Header-controlled loops. The statement block between while and end while continuously executes until the specified condition is no longer met. The condition is always checked before executing the statement block. Read loops. The select loop reads several entries of a database table in succession. In an internal table or table variable in the program, the same read function is implemented with the loop.
in the ABAP source code, you can use several data objects without explicitly declaring them previously. For example, SY_datum and SY_index. The runtime system uses these system fields to provide the application program with information about the actual system status. The table shows several system fields. You will find a complete list of system fields in the keyword documentation under the term System Fields.
One of the most important system fields is the SY_rc field. With many statements, it is supplied by the ABAP runtime system with the corresponding return code to indicate whether the statement could be executed successfully. The value 0 means that the statement was executed successfully. Read the keyword documentation for the respective statements to find out if and how this return value is set in individual cases. You use the message statement to send dialog messages to the users of your program. Specify the 3-digit message number and the message class when using the message statement. Message number and message class clearly identify the message to be displayed. Use the message type to specify where you want the message to be displayed. You can test the display behavior for various message types by means of the demo messages demonstration program that is delivered with the SAP standard system. If the specified message contains placeholders, supply them with values from your program by using the with addition. Instead of the placeholders, the transferred values appear in the displayed message text. For further information about syntactical alternatives to the message statement, refer to the keyword documentation.
The two ways of starting a program in debugging mode from the Object Navigator are as follows. In the navigation area for the selected program, choose Execute, Debugging. In the ABAP Editor area, select the requested program line from which you wish to debug. Choose the Set or Delete Breakpoint push button. Start the program by pressing F8, or in the navigation area, choose Execute, Direct. The above described setting of a breakpoint in the ABAP Editor is only possible for active source texts.
If you want to debug a certain function of a program, start the program without the ABAP Debugger and then switch to debug mode immediately before executing the function. For example, push button. Ways of switching to debugging at runtime. Choose System, Utilities, Debugging ABAP or Screen. Enter /H in the command field in the standard toolbar and press Enter.
In the ABAP Debugger, you can choose single-step processing to execute the program statement by statement. Moreover, you can display data objects and their current content in the variable display. Simply enter the name of the data object in the variable display. Alternatively, you can double-click on the data object name in the source code to transfer the variable name into the debugger field list.
In the new ABAP Debugger, you can set a breakpoint with a single click before the line in the source code. In the classic ABAP Debugger, you do this with double-click. You can also set a breakpoint for specific ABAP statements by choosing breakpoints. Breakpoint at statement. If you choose Continue, the program executes up to the next breakpoint. The set breakpoints are only valid for the current ABAP Debugger session. However, if you choose Save, the breakpoints will stay in place for the duration of your current SAP session.
Watch points are breakpoints that depend on the field content. If you set a watch point without specifying a relational operator and a comparative value on a field and choose Continue, the program executes until the content of the field changes. If you specify the relational operator and the comparative value, the program executes until the specified condition is met. In the classic ABAP Debugger, you can set a maximum of 10 watch points. You can link the watch points using a logical operator such as AND or OR in the same way as in the new ABAP Debugger. If you want to change the content of a field during debugging, double-click the pencil icon in the variable display. The value is then ready for input. Now, change the field value and confirm it by pressing Enter. The value changes while the ABAP Debugger is running. In the classic ABAP Debugger, you can change the content directly in the field view. You then click the pencil icon to accept the changed value. The new ABAP Debugger allows the following additional functions.
The new ABAP Debugger of SAP NetWeaver 7.0 EHP2 has the following features.